Okay, record. Right, so if you want to solve this simultaneous equations, what do you do usually? Here's what you do. Let me copy this down to a new page because I realize I need more space. Here is what you would do. You'll call this equation 1, equation 2. Okay, I'll call this number 1, school style, secondary school style. Equation 1, equation 2, then what do you do next? You can do, let me show you what is not relevant to this lesson. You try substitution. So what you could do is, from equation 1, you try to make x a subject. So x equals to 11 minus 5y over 8. Right, then you call this equation 3. Then you sub 3 into 2. Then what do you get? You get 4 times x, which is a horrible expression involving fractions, minus 7y equals 15, even though it works. Now 4 and 8 cancel away. This is 1, 2. You're left with 11 minus 5y over 2 minus 7y equals to 15. Multiply by 2 throughout, you get 11 minus 5y minus 14y equals to 30. Yes? And 11 minus 5 minus 14 become minus 19y equals to 30. Minus 19y equals to 30 minus away 11. This gives you 19. Negative 19y equals to 19. So therefore y equals to negative 1. Divide by negative 19. Okay so far? Yes, right? I'm going quite fast, but you get a procedure, huh? Just a recap only. Huh? Not sure?
Okay.
Can okay, then
Okay,
x
okay.
equals to 11 minus 5 times the y, which is negative 1, divided by 8. Type in the calculator, you will get your positive 2. Okay? 11 plus 6 over 8, 2. Minus 5 times minus 1 is positive 5. Good. That is substitution, not relevant to the lesson today. We're going to do the other method, which is known as... What's the method called?
Substitution.
No, this was substitution. Now I want to talk about the other method, which is... Can you guess?
Elimination.
Elimination.
But
How do you do elimination? What do you do?
I actually don't know.
Don't know. You make okay, 2 ways. You either make the one of the letters. Let's say I pick x because I see 4 and 8 are multiples of each other already. You either okay, so let's just say I pick x. Then what you do is you look at the number in front, you make them the same value but different sign. So that when you add them together, they will eliminate each other. A few ways you can present
okay.
it. Let's say I start with 2, I can multiply by 2. Then I end up with what? 8x minus 14y equals to 30, correct? Then after that, what can I do? Here's what I could do. I'll call this equation 3. Then I'll take equation 1 minus away equation 3, right? Let's do it systematically. 8x plus 5y equals minus 8x minus 14y. Wow, so squeezy. Look, I want my equal sign to be aligned nicely in the middle, to be neat and systematic. But here, wow, no space. Then what should I do? So here's what I should do. Write it at the bottom instead. Minus bracket, just like long division, a bit similar to long division. Write it below. Neat and tidy. Now this is equation 1 minus away equation 3, the left-hand side of equation 1 minus away left-hand side of equation 3. Now we do it for the right-hand side. So right-hand side minus away right-hand side. So we're going to take equation 1's right-hand side, 11, minus away 30. Is that clear? And following good. Then now maybe it will be even neater if I just write it like this, minus 30. Then I draw a line. As if I'm doing primary school subtraction or something like that. 8x minus away 8x, it eliminates each other. Do you see that? Then how about plus 5 minus 14? How about my plus 5 minus 14? I'll wait for you.
19y.
19, very good. 19y equals to this one?
Negative 19.
You realize that it's the same as before. Over here, negative 19y equals to 19. Over here, right?
Yeah.
Then therefore you can solve for y. You end up with negative 19 over 19, which is negative 1. Good. Then from there, you substitute the negative 1 and you solve for x. Okay, so which equation do you pick? Doesn't matter. doesn't matter. Oh, so what you can do is maybe I will do the following. I will substitute back into the first equation. So sub y equals -1 into equation 1. Then I end up with 8x plus 5 times -1 equals to 11. And from there I can solve for x. So it's just 4. Is it 4? No, it's 2. Right, because this is -5, you bring it over, it becomes a +5. So you end up with, if I show a bit more working, 8x minus 5 equals 11. 8x equals to 11 plus 5, which is 16. So 8x equals 16, therefore 8x equals to 16 divided by 8 equals to 2. So far, so easy, right? Can no confusion.
Mhm.
This is just introduction only. I haven't got to the main topic. Clear or not?
Okay.
Any part not clear? New topic incoming now.
No.
Okay, now we're gonna copy and paste the entire working. This is lesson part 2 of the lesson. We're gonna be a bit more systematic here. What did I say? Remove the letters, coefficient remains. So notice how I usually write very messily, but this time I was very precise. How? I was very precise in the sense that I make sure that my equal signs are all aligned in the middle. Let me try and be even neater. Make sure all of my equal signs are aligned. Actually, this is not so neat. Let me shift this a bit. Shift this a bit back. I know why it's moving all. Okay. Shift it. Shift it. Notice how I am purposely aligning all of my equal signs in the middle. I can just get Notability to stop moving crazily. That would be good. And here, okay, can. So that was just a copy paste of the previous working. Notice that the equal signs are all aligned, yes? Notice that all the y's are aligned here. Can you see? Notice all the x are aligned over here. Notice all the constants are on the right side. Can you see that? Now I'm going to box up the ones that I don't want in pink. Okay, this is intermediate working. This part also intermediate working. I don't care. Eliminate. Okay, wait. No. I need to keep number 3. This part is intermediate working. I can just chop it off. Okay. This part is sub y equals -1 into 1. That's obvious. I chop it off. This part is just intermediate working. Chop it off. This part is just working. Mental sums. Throw it to the side. After practice, you can do it in your head. Hopefully. I don't know. Just write it down at the side. Okay? Can? So how do you present this neatly? That's what we could do. I'm going to copy and paste this again. But this time, I erase away all the details. Away all the details. Neat and tidy. Here's what's really going on. This is all you need when you're solving simultaneous equations. Can we be even neater? Can. You see, because I purposely make sure all of my x is on the left and y is on the right, followed by an equal sign, followed by the constants on the right-hand side, I can do the following. Why don't we just chop off the equal sign? Lazy, I don't want to write equal sign. 2 lines, more efficient. Draw a single line. And notice, you see how every time you take equation 2 times 2, what's going on? You're just multiplying 2 to the 4, 2 to the -7. So where is the action happening? The action is happening on the numbers in front of the letters, correct? Only the 4 changes, only the number 4 changes and the -7 changes to a 8 and a -14. So what happens to your x and y? It just stays there, right? So how about if I do the following? I chop off all the x. I chop off all the y. I just put down x at the top, y at the top as a label. Same meaning, right? Oh, then, wow, you see, this one's so lazy. I'm very lazy. You see, it's two separate lines, so slow. If only there was a faster way. Yes, we just draw a single line. Label equation 1 and 2. Don't want so lazy. Just know that the top row is always your row 1, bottom row is always your row 2. Then to make things nice and tidy, how about if I just open a bracket here, close the bracket here. I compare and contrast with before. You see, previously you have to write so many lines. Okay, 2 times 2, write down the x, write down the y, label equation 3, sub 1 minus 3, draw bracket, minus, blah, 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 blah. We chop off all the details because we are beyond secondary school now. We already know the details. It's at the back of our head. We just chop off the details, don't need. Do you understand what's going on?
Okay.
Okay, but here I made a slight error. Instead of chopping off the y's, there's actually an invisible 1 over here. There was an invisible 1 over here, 1x and 1y. I only want to chop off the letter. I want to keep the coefficients. Is it clear?
Okay.
Okay, and this one, equation 3, a bit confusing. So here, I'm gonna present a new way of doing it. This is called row reduction. Just for reference, I'm gonna copy and paste whatever we had before, but on the right side. Then now I redo the question, okay? But without. Wow, stop moving. Notability. Paid for this software and it's not working well. So sad. I'm gonna redo this question, but this time I'm gonna put an x as a header, y as a header, and then I'm just gonna list down the coefficients. So there's a 8, there's a 5, there's a 4, there's a -7. Then I just draw an open bracket, open matrix, and then I draw a vertical line. Then I draw 11 and 15. Close the bracket. I'll call this row number 1, row number 2. You don't have to label row 1 and row 2. So you notice how I managed to obtain after taking some after multiplying 2 to this equation 2, and then I subtract it. I relabel it as 3, and then I subtract it away from equation 1, right? Here's the new notation for that. To summarize what I did when I take equation 2 times 2, and then I call it equation 3, and then I take 1 minus way 3. This can all be summarized as row 2, you multiply it by 2. This is equation 3. Then you take equation 1, you subtract away, you take row 1, you subtract away 2 copies of row 2. And you use this to replace, okay, sorry, before I say the replacement. Notice how this 4x minus 7y, after you times 2, you get this new equation, correct? Yes? This 8x minus 14y came from 4x minus 7y. So that means the information they provide is equivalent. So that's why we don't need equation 2 anymore after we times 2. We only need this guy and equation 1. So that means who is useless now after you times 2? This old guy. Oh, this one sounds a bit better. Like this is the mom. The mom gives birth to the child and you can eliminate the mom. Oh no, this sounds very bad. Cannot say this. You replace. So no more already. Don't need. Just get a new one. Make sense? Just joking. Just joking. So this one, you're gonna replace the second equation. If I can move notability nicely. I just want to move it a few lines above and it moves the whole screen. How do I not do that? Don't understand. Okay. Just want to shift it one line above and I can't do that. Okay, so what was I saying? I'm saying that this guy is no longer relevant. So how about if we replace it entirely? Okay. Let me think if I'm saying this correctly. Not correct. Not correct. I should have started with the other order. Can I just do something? I'm so sorry. Can I just swap it around? I'm gonna swap the
Okay.
order. 8, 5, 11. I'm gonna bring it to the bottom instead. And then I call it row 1, row 2. Oh, that's very messy. Can I relabel the equations first? 1 second. Is it okay if I redo the simultaneous equations so it's easier to explain?
Okay, okay.
And sorry, bad planning. I should have picked a smaller coefficient on the numerator. What? Cannot. Bad example. Sorry. Should have swapped it around. So what I just did was to swap the bottom, top and bottom rows. I swapped the order. All right. What I'm gonna do next is, I will take my equation 1 this time and I times 2. So I get 8x minus 14y. I get equation 3. Right. Then what I'm gonna do is I'm gonna take my equation 2. I subtract away equation 3 from it. What does that mean? It means that I take my equation 2, which is 8x plus 5y. Then you minus away equation 3, which is 8x minus 14y. It's the same thing, right? It's the same thing. Get back to 19y. Y equals -1. I just relabel the equation. Is that okay? Okay, good. So that means that now we have y equals -1. You can also substitute back in and then you can solve for your x. So if you sub y equals to -1 into equation, let's say 1, then this will give you 4x minus 7 times -1 equals to 15. Therefore, 4x equals to 15 plus 7, which is some value. This is 22. I see wrongly. No. -7 times -1 is +7. You bring it over, you get -7, which is 8. So 4x equal to 8, therefore x equals to 8 divided by 2, which is 4. 4. Is that okay?
Yep.
I'm getting confused. Oh my goodness. 8 divided by 4 is 2. 8 divided by 4 is 2. Can? Okay, good. So that means that now we have all this. I have to say the sorry again. Sorry. Let me try again. This time you want the equal signs to be aligned neatly. Then you realize that, oh, the equal signs are all aligned. The y's are all aligned. Not really, but let me try and do that. Make them aligned. Right? The y's are all aligned, and all the x are aligned. Constants also all aligned. Then you chop off the details. So we're gonna chop off the details. Let me just try again. I don't need this. Don't need this. Don't need this. I need this. I don't need this. I also don't need these. But I need this. Okay, so what was I saying? So what you see is that essentially what you're doing is this equation 3 came from equation 1. It came from equation 1. So that means that this is the mom, this is the child. You can chop off the mom. Replace the mom with the child. Does it make sense?
Okay.
Or more like the equation. Wait, 对不对 ah? Let me say again. I shouldn't be saying replace the mom. No. I'm getting mixed up. Let me think again. Oh no, let me try again. Okay, let me try again. Okay, so what we are doing is we are taking equation 1, we multiply by 2. Then we get this updated equation, equation 3. Then we subtract this equation 3 from equation 2. Essentially, if I just change the notation to row 1 and row 2, what this means is I have 1 times 2. This is what, right? 1 times 2, this is equation 3. Then I take equation 2, I subtract away equation 3. In terms of the R1 and R2, row number 1 and row number 2 notation, that will mean I take row 1, I times 2, that's my equation 3. Then I take equation 2, which is row 2, I subtract away my equation 3. So who actually gets, who should actually be updated here? Who should actually be updated here? Actually, it should be 19y equals negative 19. This guy should be the new updated version, right? Can you see why?
Right.
You take 2 copies of this equation 1, you subtract it away from equation 2. That means that you take away equation 2. So this becomes 0x. Then this becomes a positive 19y. This becomes a negative 19. Can you see that?
Yeah.
So what we are doing is we are essentially replacing row 2. So you write this down. Row 2 replaced with row 2 minus row 1 times 2. Does that make sense? This is essentially the procedure we are doing over here, but written in a different language. This arrow here means replace, replaces. No, this arrow here means assignment, or more like row 2 is replaced with the right-hand side. It's replaced with. Is that okay?
Mm-hmm.
Okay, good. So what we're gonna do now is to just summarize the information by writing a single arrow. How should I present this? Not enough space, like. Let me shrink things down a bit. I will just write this as action number 1, dot dot. Then I will draw a single arrow here, I put a 1. And then I update my what I call the matrix. This is a matrix. Then what we're gonna do is we're gonna replace the row 2 with row 2 minus 2 copies of row 1. So what we do is essentially this row 1 is 4 minus 7, 15. Let's write it down. 4 minus 7 and 15. We're gonna times 2 to it. This gives us 8, negative 14, 40. And then we're gonna take row 2 minus away 2 copies of row 1. This fella here is R1 times 2. What we're gonna do is we're gonna take this, we're gonna take this, we're gonna take the top guy minus away the bottom guy. This is essentially 8x. There is essentially 8x. You subtract away 8x from 8x, what are you left with? You're just left with what? 0. Just like over here, we have a 0x plus 19y. And then if you continue, here you're left with a 5y. Here you have a minus 14y. You're subtracting it. So 5y minus away negative 14y gives you a what? Five y minus away negative 14y. What does that give you?
Give you 19y.
19y. But to be more efficient, we don't write 19. Why? We write just 19. So we update this 5 here with a 19.
19.
Okay, and likewise for the constant, you're gonna have the original 11 minus away the 30. So 11 minus 30 gives you negative 19. Compare and contrast with the previous working we did using simultaneous equation. Can you understand how they are equivalent? The only thing that the only action that takes place is in the numbers. I highlight the numbers for you. So draw 1 here. There's also an invisible 1 in front of the x. Oh. Can you see how we essentially replace the row 2 with this guy here? You see that? 8, 5, 11 becomes 0, 19, minus 19. Can understand?
Yeah.
Yes, so now we have 19y equals to negative 19. The next line, what we're going to do is, okay, this one, this working out, I will just put it at the side. The next line, what we're going to do is draw another line. Okay, might be neater if I just do the following. I will present it like this. I have to shrink this down due to a lack of space. These are details. I don't need this. I don't need this. I also don't really need this. All I need is number 1 here. Okay. Then what I'm gonna do next is I draw another arrow. I put a 2 here. This is action 2. What I'm gonna do next is I want to solve for y, right? So how do you go from 19y equals to negative 19 into 1y equals negative 1? Divide by 19, right? Divide by 19. In terms of the row action, what we are doing is essentially we copy down everything that we are not touching, which is the row 1. But notice how this new pink color numbers is your new row 2. Does it make sense? Then what we are doing right now is we are taking row 2. Oops, wait a minute. We're taking our row 2. We multiply it by 1 over 19. Make sense?
Yeah.
19y equals negative 19. So left and right, you multiply 1 over 19, 1 over 19. This will cancel away the 19, you're left with a y. Cancel away the 19, left with negative 1. But in a very succinct, what do you say, concise notation, it's just R2 times 1 over 19. And you're gonna use this to replace the original R2, row 2. That is my action number 2, dot. Okay? Then this becomes what? Isn't it just 0 divided by 19, 0? 19 divided by 19, you get 1. Negative 19 divided by negative 19, negative 1. This is a new R1 and R2. Okay? So that means we already solved it. 1y equals to negative 1. Then what do we do next? What we did next over here, we sub y equal negative 1 into equation 1, right? So what this means is, essentially, here's what we can do. Yeah, I'll delete this. We can think of it like this. There's a negative 7y on top here, right? You see? It's actually 4x minus 7y equals to 15. This is 0x plus 1y equals to negative 1. But we don't write the x. We don't write the 1. Okay. So how can we solve for x? What we can do is this guy at the top, we try to eliminate it. So what do we do? How about this? We take 7 copies of our row 2. So that essentially means 1y equals negative 1. You take 7 copies, so it becomes 7y equals negative 7. Then previously we got 4 minus 7, 15. What does it mean? 4x minus 7y equals to 15. How do we get rid of this negative 7y? With our 7y that we just obtained from 7 times R2. That is plus, here is minus. What do you want to do? Hello? Huh? Mic test, can you hear me?
Yeah.
So what do you want to do to get rid of the minus 7y?
Yeah, what? How?
1 is plus, 1 is minus. Add them. You see? Just add them together. Simultaneous equation. Call this equation star. Call this equation double star. Star plus double star.
Okay.
This will give you what? 4x minus 7y plus 7y. So the 7y's will cancel away. And 5 plus negative 7. That will give you 9. That will give you 8. But that's exactly the same as this working over here. Do you see that?
Mm-hmm.
Substituting y equals -1 is the same as multiplying by 7 here to get positive 7y, and you add on to the old equation. So in other words, what we're doing is you take 7 copies of your row 2, you get positive 7y, you add on to your row 1. So we're gonna write down row 1 here. And we add on 7 copies of row 2. Then we're gonna use this to replace row 1. That's my action number 3. Use this to replace row 1. Let's see what happens. So what we end up obtaining is 0 here, 1 here, -1 here. But after you multiply by 7, you get essentially 7, -1, 0, 7, -1, and you add on to the row 1. You add on to the row 1. Okay, where's my highlighter? Why is the... Right, you take this, and then you add on to your row 1. So what do you get? 4 plus 0 gives you 4. 7 plus -7 gives you 0. -1 plus 15 gives you 14. Eh? You realize. Wait a minute. This is 4x equals to 14. Hold on, something is wrong. Yeah, I made a mistake. Wait, over here should be -7. Let me try again. Here is 1 minus 0, 1 minus 1. You times 7, you get 0, 7 minus 7. With the 0, 7 minus 7, you add on to your row 1 and you get your new equation. Let me try again now. Sorry, I times 7, I get this new row, 0, 7, -7. You add on to your row 1. Let's see what happens. 0 plus a 4. Get a 4. 7 plus a -7. You get a 0. -7 plus a 15. What do you get? 8. Right? Then you see, it's the same as this one. 4x equal to 8. What does that mean? It means that we are mimicking the simultaneous equations, but with a lot less writing. No x, no y, just a bunch of squares and lines. Is that okay? 听得懂吗?
Yeah.
Right? Then here, what this essentially means is it's a shortcut for writing 4x equals to 8. Equals to 8. Then how do you solve for x now? One last step. Divide by 4. So here's how you write it. You're gonna write down action number... Erase all details. Action number 4. We're gonna take row 1, but we multiply by 1/4. And we're gonna take this resulting result and replace it. And we replace the original row 1 with the thing that we have just obtained. 1/4 of row. We take 1/4 of row 1 and we replace the original row 1. This arrow here means replace. With row 1 is replaced with 1/4 of row 1. Does that make sense?
Mm-hmm.
It's like, and if you did programming area, it's like x equals to x minus 1. What does that mean? X equal to 4, x equal to x minus 1, print x. What do you get? Do you know this? Have you learned coding already?
Oh, no.
Okay, this this is not a normal equation. So if you see in Python, you get something like x equal to 4, x equal to x minus 1, then print x. what they're telling you is, we're gonna create a box. This box has a name. Hi, my name is X. And inside the X, when you put on the first line, this is line 1, line 2, then line 3. Line 1 says X equal to 4, right? It's not equal. It's assignment. It's just like the arrow I'm writing just now. I'm assigning X with 4. In other words, inside this box, I'm going to put in something. It is a 4. I'm going to put it inside. So now there's a box that contains a number, and the number is called 4. Can you understand this concept? My name is X. That's the name of the box. We're going to put a 4 inside the box. That's what X equal to 4 means. Then the next line, X equal to X minus 1. It's not an equation. It's not a math equation anymore. You minus X on both sides, then 0 equals 0 minus 1, then 0 equals negative 1. No. This is not a math equation. This equal is not equal. In computer science, they are using the equal sign to mean a different thing. It means assignment or replace. X is going to be replaced with X minus 1. Then we must calculate from the right-hand side first. What is X minus 1? X is 4, right? So what's X minus 1? Tell me. Hello? Mic test. Is the audio okay? Can you hear me?
Yeah.
So what is X minus 1? X is 4, right? So therefore, substitute in what you get.
3.
3. So X minus 1 here is 3. Then here, if you read the English, it's read differently. It's not equal. It's replaced with X is replaced with 3. So that means that what we are doing is, in this picture, we are chopping off the 4 and replacing it with a 3. So now you print X. What do you expect to be printed out? X is 3. When you print X, what you're doing is you're finding the box, and then you open up the box and you see what present you have inside. Oh, the present inside is a 3. So you print X, you get a 3 as your output. Does it make sense?
Yeah.
Can understand now? I'm doing the exact same thing with the assignment. Okay, Ken. And when you haven't learned programming, so it doesn't make sense. I can't relate to that. Okay, Ken. So just not understand a new idea known as the replacement, or is replaced with assignment. It's called assignment. The assignment operation. Replace with. We are replacing, in this case, what does it mean? Can you read for me in English? What does this sentence mean? Yeah or not? Are you very confused? This is whereas row 1. What's the arrow representing? Assignment. Or you can read as is replaced with.
Okay.
So row 1 is replaced with row 1, the old row 1 times 1/4. Maybe I write it in English. The new row 1. No, I shouldn't say that. I should say row 1 is replaced with the old row 1 but times 1/4. So here is the old row 1. You times 1/4 to it, what do you get? As an intermediate working, you end up with 1 here, 0 here, divided by 4, you get 2 here. And then we're gonna take this guy and replace the row 1 with this new guy. So you end up with 1, 0, 2. And then you copy down the old row like this. How do you interpret this? What this means is essentially 1x plus a 0y equals 2, 0x plus a 1y equals -1. Therefore, x equal to 2, y equals -1.